it's an honour to introduce Ulrich here, who I got to know Ulrich in 2007, courtesy of David Bellamy, because David Bellamy knew us both and knew that we were doing overlapping things, you might say. And I've studied various effects of the planets on the Sun and therefore on the Earth, and Ulrich has got many original findings on this front, which he's going to talk to us about. And I think it does overlap in a lot of ways with different ideas in electric universe, because it would be a modulation or an effect on the Sun-Earth connection, which could be via Birkeland currents, for example. But we're not going to talk about those in particular, I think, right now, but Ulrich will explain all the different things he's got to say, which are, you know, important original findings. So, over to you, Ulrich.
Okay, I'm going to run through some presentation of. I'm going to get right to the core of it and actually show you the findings as soon as possible, rather than talk too much. Firstly, to introduce the subject, I'm going to start with a planetary ordering of sunspot cycles and of centennial solar minima. So, roughly every 100 years and a bit, or on average every 10 cycles, we get a solar minimum, like for example the Spora Dalton Maunder minimum in the what we call the Little Ice Age, and these events are regularly occurring on average every 10 cycles. It could be 7 cycles, it could be 12, so the intervals are quite variable. The lengths are very variable too. It could affect 2 cycles, it could affect 5 sunspot cycles. From at least the 1800s, a few people have noted that the synodic cycles of Earth, Venus and Jupiter, which is of the 3 I'm showing at the moment, I'll bring the labels up, there we go, Sun in the middle, Venus, Earth, Jupiter. The synodic cycles of these planets follow sunspot cycles. They don't go out of sync with sunspot cycles over long periods, but they don't tell you anything else. They don't tell you the exact placement of each sunspot cycle maximum, and they don't give any information on sunspot cycle minimum, particularly solar minima, centennial solar minima. We get no information from this series. Now I'm going to be animating Earth and Venus in half synodic periods of the 2 planets. I'm going to. So normally the planets are obviously marching around the Sun this way, but I'm going to be jumping from oppositions to conjunctions because I'm looking at specific geometries. So we're going to get right into it straight away and look at. I'm going to get some corresponding data of sunspot cycles up since the 1600s. Our first maximum target is sunspot cycle maximum of 1615. Can you hear me? Sorry, can you hear me right?
Yes, definitely.
So, at this point I'm going to introduce Uranus, and by integrating Uranus with the synodic periods of the primary triplet, I can't see my buttons very well, there we go, we can actually successfully start to track each sunspot maximum and where the grand solar minima or the centennial solar minima will occur. Now the rules are that the Earth-Venus conjunctions, that one and that one, will have to be roughly in line with Uranus, and in one cycle, it should be even numbered. Is it even or odds? I think it's the even number. Even numbered cycles, we've got Jupiter in line with Uranus, and the next cycle, which is effectively, note this, we're going to move around Jupiter around 3/4 of a synodic cycle relative to Uranus to get to the next sunspot cycle maximum, where Earth-Venus conjunctions again here are lining up with Uranus. That's the pattern. The next one will be 3/4 of a Jupiter-Uranus synodic period around, and now Jupiter's on the other side of the Sun in line conjunct to Uranus. Again, we've got the Earth-Venus conjuncts lining up with Uranus is the target. Dates I should have got 16, 15, 26, and we give 39.5 here. I don't know how accurate that is back then. What do you reckon, Piers?
Well,
It's going to be a bit shaky with
yeah,
the
it could be a year out easily.
So I'm not too worried about the accuracy
No.
back in that century. This mapped it out as 16, 17, 1627, somewhere around late 37 into 38, it's fairly close. Now, the synodic periods of the primary triplet of Earth, Venus and Jupiter is roughly about 11 years. This focus to Uranus is stronger. It's shorter. And when those solar cycles are occurring, we're actually getting shorter solar cycles. So the run of, I mean, in the 20th century, it's 7 out of 9 cycles are only about 10.4
Yeah, that's
years.
true. That's
That
true.
explains that period. But also, because that period is shorter, the positions of the alignment of Jupiter and Earth and Venus lining up with, Earth and Venus is slipping against Jupiter by the time Uranus lines up with Uranus. So because they're different periods, one's about 10.4 years, and one's about 11. So they're starting to slip.
Yeah.
And what happens? I'm going to go. Where am I now? I'm up in the mid 1660s, and where the next one should occur, there's so much slip that that quadrupole geometry here, see, it won't fit anymore, and the next sunspot cycle then occurs with a quadrupole alignment with Neptune at 1675 here. And then the following cycles through the rest of the Maunder minimum will be aligning with Jupiter. Earth, Venus will be aligning with Jupiter rather than Uranus. So we're going to apply the same rule of 3/4 of a synodic period to get to the next maximum, but with Neptune rather than Uranus. So the next maximum should be there,
Sorry, Neptune rather than Uranus.
which is 1683/4, and the next one, and we'll repeat that again, the next maximum should be there at 1693, because they can't physically do a quadrupole alignment with Uranus anymore, and that's why solar minimum occur, because the shorter period of Earth, Venus and Uranus slips out of alignment with the Jupiter synodic periods. And just to confirm, we've got 1685 and 1693. That one was within a year or so, and that one's bang on. The period of the slip of the primary triplet with Neptune is even faster. So looking for where the next maximum might be with that one, it's already slipped too far, and it's going to come back. At that point, it can regain the original synchronicity with Uranus at, I have 1706. Here, 1705.5, and then we're out of the solar minimum, out of the Dalton minimum. There's only actually 3 cycles that are Neptune based through the Dalton minimum, and that's exactly what central England temperatures show, that the cold starts about 1702 near a sunspot maximum, and continues for 3 cycles maximum to maximum until 1705. So northern, that's where, you know, England, northwest West Europe, that's when the cold was really seen. So talk of Maunder minimum starting back in 1645. Okay, there was a lack of sunspots maybe, but England was roasting in the early 1650s. The 1660s was
Well, yeah, the Fire of London.
Yeah, the Fire of London in 1666. There's only a couple of years. The cold properly comes in when actually the model shows it does at around the early 1670s. Okay, we're going to zoom. I'm going to try and speed up now. Now you're hopefully following the pattern. I'm going to run through. I'm going to confirm a few more dates. There's where the next non-solar minimum maximum should be, 1617. The next one should be here, Earth and Venus in line with Uranus, Jupiter roughly in line. We've got 1627. Next one should be around here. And we're still maintaining a good geometry, so I've got 38, so I'm looking at 17, it was within the year, that's within a half a year, that's within a year and a bit. Now watch, Earth and Venus starting to slip out when Jupiter's in line. Next one is around here. Earth and Venus slipping out more. Get Jupiter, Uranus in at the same time, zoom out, there we go. The next one should be here, and look how much slip we've got now. Earth and Venus not lining up with Uranus so well. It lines up there, but Jupiter's not in, so that's the difference of the periods again. Where am I? 1668, I think, 1768. Now the commencement of the Dalton minimum in early 1800s. This is a really curious example. It's unlike the rest. There's an awful lot of slip of Earth and Venus before the minimum occurs. I've got an idea why. That just popped up the other day, but I won't go into that at the moment. It's still doing Uranus cycles at 1788 with that huge amount of slip there, and it eventually then slips out of its relationship with, well, the primary triplets slip out of their relationship with Uranus and do a sunspot maximum here, and that's clearly a Neptune-based alignment geometry. That's the first week cycle, and that's solar cycle number 5 in the Dalton minimum. But what's most curious about this, the amount of, it gives great evidence for the importance of Uranus. These late ones, just put in the late 1700s, are clearly pointing out that the prime evidence for the importance of Uranus in the ordering of sunspot cycles, because Uranus is the deciding factor why these are so late, running so late here. It's got nothing to do with Jupiter at all. Okay, we're going back to 1805. The next one is 1817, and then we're on to Uranus-based cycles again. We're past the Dalton minimum. So that's the basic rules at play there. We've got two different periods going on between Earth, Venus and Jupiter, and Earth, Venus and Uranus. And when they slip out of sync is when a solar minimum is going to happen. Because of there's no short-term fine harmony, some of those periods will change anyway, and plus the orbits are non-circular, is why there's so much variability in the length of solar minimum, and that's the two reasons why. So they sometimes short like Dalton and the Gleisberg minimum at the end of the 1800s, affecting 2 cycles. Sometimes they're 3 like Maunder, sometimes they're 4, sometimes they're even 5 cycles long, purely because of slips in the orbit. So you might get a pattern that's so many, 5, 5, 5, and then to get back in sync it's going to be 3 or 7. So some unusual events crop up again, now and again in the harmonics, and most important because the orbits are not circular. So you get huge variation in the length of solar minima. Like I say, 2 to 5 cycles are the extreme, and quite a bit of variation in their placing. This maps it all out. This will tell you exactly how many cycles in each solar minimum every time. So it's a bit like a time machine. You can go back and use it to verify historic climate records, tree ring series, all manner of proxy records can be finally calibrated, confirmed, or corrected by looking at solar cycles. But I've got a whole load more findings on short-term ordering of solar activity, which relates to the same quadrupolar logic. Now, everything I'm looking at is all working by quadrupolar ordering of solar activity. I'm going to splash through some of this really quick as I can. I'm going to bring back Saturn. I'm going to take out the inner planets totem. I'm going to be looking at the 4 Jovian bodies. Weather events. Hugely hot summers. 2003, 2006 was a scorcher. 1976. 1949, Piers once asked me, why was 49 so hot, Piers?
Yeah, I did.
Yeah. The answer is short-term Jovian ordering of solar activity levels.
You sure it's 49 or 47?
Sorry?
49 or 47? 47
You
was
said
it?
49.
Did I? Okay.
Yeah.
All right.
And basically,
okay.
because it's got the same order of,
Yeah,
of
it probably was
configuration,
hot as
it's
well,
not quite so acute as 1976, but it's the same type
Yeah,
of.
yeah.
There's mid 48. I'm going to go to 76 because it's the best example. Here. And the key elements is Uranus opposite Jupiter square to Saturn. Now, there's one of those in the middle of the Maunder minimum coming up to modern temperatures in 1686. And second mildest winter in English records. Isn't that right, Piers?
Yeah.
Is it the second?
I think so. But
Yeah.
I'm not sure.
And it happens on one of those.
Yeah.
1934 heat waves happened on one of those. 2003 heat wave happened on an oblique one of those.
Yeah,
Why
1934
the
was 42
T-square?
years before 1976.
This and a number of other things involving quadratures kept on cropping up in my weather studies, and I'm thinking, why do quadratures matter? So I thought, well, okay, let's go through, get all the weather records out I can, and start looking single instances of, well, what does Jupiter opposite? I think it was Tall Bloke's blog actually. There was
Roger Tallbloke.
yeah, there was a post on a whole load of English winters that were really cold, and I had a look on here and went, blimey, nearly all of them are Jupiter opposite Neptune.
Yeah.
So I thought, okay, time for a systematic study and looking for all pairs and triplets for standalone events and see what they're doing. So, and I found dozens and dozens and dozens of, through very, very long weather chronicles, of cold events happening at Jupiter opposite Neptune. And with Jupiter square to Neptune, there's loads of warm events. Now, okay, well, let's look at Saturn opposite Neptune as a standalone event without something being in closer syzygy, in line or in quadrature square to it. Loads of hot events. Well, 2006 was a notable one. What happens when our Saturn is now square to? Labels on for anyone that's not sure about where they are. Lots of cold events. Hello, very curious. So we've got Jupiter opposite Neptune, we've got cold events. Jupiter in quadrature with Neptune, cold events. Saturn's a complete opposite. When it's opposite Neptune, we've got lots of hot events. Saturn square to Neptune, we've got lots of cold events. So, okay, what does Saturn and Neptune do with Uranus? Well, the complete reverse of that. So, Jupiter opposite Uranus, we get warm events. We get cold events when it's square. Well, 2007 summer appears.
Yeah.
Bang on one of those.
Absolutely.
So what happens when Saturn's opposite Uranus? Well, the opposite of Jupiter, I think. So we get cold events. And when Saturn squares Uranus, we get warm events happening. And these things are only happening, they're happening from the quadratures and syzygies, not before, for a year or so, because Jupiter moves very fast. It's moved through 90 degrees in 3 years. So these events are just brief, sometimes even half a year. It might affect a year, it might affect 2 years at the very most, and everything's moved. So our peak weather events, hot events and cold events, are mostly due to quadrupole ordering of solar activity levels. If we look at the solar wind speed and strength around 2003 and 1976, where the example I gave you, the hot T-square, they're the strongest solar wind periods in the whole space age since solar wind measurements were taken, happened on that configuration, which is treble hot. We've got a hot opposition, we've got a hot square, and this square is also hot. The rules with Saturn and Jupiter are hot in square and cold in opposition, the exact opposite of what Neptune and Uranus do, curiously again, because they're actually colder in quadrature, in square.
Okay.
So there's these curious polarities going on through, with the bodies respectively, and everything plays out through quadrupole ordering of the Sun, and it must relate to, the planets can't affect the Sun, but there's strong magnetic ropes connections from each planet, from the Sun to each planet, which is somehow this is affecting the quadrupole magnetic moment of the Sun, which is around its equator. The dipole is through the polar regions. The Sun has a quadrupolar moment around its equatorial band. I don't know how it's doing it, but I can't see any other way for this to be taking place, but by the Sun's magnetic connections to each body and affecting its quadrupole magnetic moment somehow. It's all guesswork after that, but the evidence is extremely consistent. These things are always hot, unless Neptune comes into line and changes the logic, the order of it. That's the only exceptions that I've found. When you've got Neptune sitting here or here, it's going to bring in some a cold aspect here, for example, and a cold aspect against Saturn here.
Brilliant.
Okay, thank you.
Yeah,
Does anyone have any
quick question? Quick question?
Shall I do a bit? Ulrich, do you want to explain what therefore might happen during the coming minimum period?
Just to tie off the end of that, there's another set of rules that apply to Earth and Venus within each of these configurations that come up that might be hot or cold, which actually then decide where the at the very much smaller scales where the hot and the cold bits of weather will be, which is what I found, which you know about, Piers, because that's what I found back in late 2007.
Absolutely.
So in this given configuration here, the hot stuff's going to start from there. When the Earth-Venus bisector hits the Saturn line, when the Earth-Venus bisector starts there, you're going to start a weaker bit of solar activity there. And then when the Earth-Venus bisector is rounding in line with Saturn again that side, then you're going to see solar activity increase. And then from that point you'll see it decrease. From this point you'll see it increase. Get the pattern? So we've got a cold stuff starting on this line and warm stuff starting on that line. So but it's not either. It's not either. The most important thing, it kicks off most strongly at the Earth-Venus bisector, right? When they're both sitting there. That's when you see the big change. From then, not leading up to it, but from then. That's what I'm seeing in all the data. Click, something, send you, up goes the activity. As soon as that bisector hits the Jupiter-Uranus line, that's when you see the activity go down again and you see the cold weather coming in. So we can look really at fine detail now within each configuration at the scale of weather.
Yeah,
And
Lucy's asking us when in this model.
And it all relates to the same quadrupole logic. And for example, if this is really important, if Jupiter is now this side, the hot and cold lines all move by 90 degrees. So
Okay.
it'll be cold towards Saturn and warmer towards Jupiter and Neptune, and that applies to if I swap that for Neptune and left those like that, the same thing would happen. The cold line would be here. So there's curious things that relate to the Jovian logic that totally relate to this logic too. It's all commensurate. Totally.
That's fantastic.
So that's the three levels of it. It's the ordering of the sunspot cycle, this Jovian logic at short term, and even shorter term stuff to do with the positions, and they all agree in their logic.
No, I think that is brilliant.
Thank you very much.
It all meshes
Do you
together.
want to give us?
It's all part of the same phenomenon.
I think that's fantastic. Do you want to give us your view of when the coldest part of the coming cold may be?
Well, looking at the records, looking at Dalton minimum,
Yeah.
you've got the coldest bit between 1807 to 1817, which is from a sunspot maximum
but the
plus
future
1
one.
year.
Yeah, the future one.
Future
What-
one.
And the
What's
same
coming?
pattern in, because, well,
Okay.
that's
But where are we going to be? 2030, 2035,
because when the
2020?
sun's weak,
Yeah, we kind of got the point, Europe, but when is the future one going to happen? What's the next
What's
one?
the future?
What does your computer program show?
the next solar minimum,
Yeah, well, the next,
Or
the
the-
next alignment.
The overall minimum, like the
The
oh,
alignment.
so I'm not understanding the question. You want to,
We're worried about when we're going to freeze.
Yeah,
Yeah,
when's the next
what's the
one?
future
When
prediction?
are we going to freeze?
okay, this solar minimum is a short one.
No, it's not just. Well, you're saying that it's the alignments are the important thing, and you're saying that the alignment of these various planets is what's making the difference. We would like to know when is the next critical alignment, the future alignment, not the one in the 18th century.
What, for a cold winter?
a whole series of cold
Oh,
winters.
no, like,
Oh, there's just so much detail. And what really matters at a mankind level is when the next major solar minimum's going to
Okay.
happen.
And when is
It
that?
will not be this one. This one's only maxed out at 2 cycles.
Is it 2030, 2035, 2025?
How long have we got?
Okay. Let's have a
yeah, like,
I'm struggling to think of 2030.
Have I got 3 minutes left?
No.
No, we cannot 3 minutes, we can't do that.
Give me 3 minutes and I'll run you
I think
through.
we just need to. we
Why
need
is
to move
Mars
on.
You ask a question, you've got to
I know,
answer.
I know.
Okay.
Mars.
Um,
Don't worry about Mars. Ask him afterwards.
okay, well, I'm just looking at 2016.
It's got to be about 2030 or something. isn't it?
Okay,
There you are.
1990 we had the sunspot cycle, then we had the sunspot cycle in 2000. Next one, there's far too much slip here.
Yeah.
It didn't happen in 2010. So it came round and hooked into Uranus 2020. In fact, it started kicking off about there, didn't it? And then it finished properly about 2015. It did have a little hiccup in 2014 when it was square to Uranus for some strange reason. So Pluto, that didn't anything. But anyway, second peak in 2015.
Yeah, but we're
So-
looking
so-
for another Dalton
Hang on, hang on.
minimum, you see.
So hang on. If I go around to here, I'm going to get the next sunspot maximum in 2025.
Yeah.
It will double peak against Uranus in 2027, and then past that we're back onto Uranus cycles. It's a very short solar minimum,
Okay.
and the worst of the weather is going to be between the sunspot cycle that's just gone and the one that's coming.
Okay.
There might be a few splatters past that, past 2025, but the worst window is between now and 2025.
Oh, okay.
Weather-wise, and you know how we had a few cold bits
Yeah,
before
yeah.
this sunspot. We had cold winters in 2010
We did.
and 2013.
Yeah.
You'll see a few more splatters of those past 2025 when they're out of the solar minimum. Then the next two, most importantly, for the long term, the next 2 solar minimum are huge.
when?
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 From the late 2090s and from 2200s, it's going to seriously challenge mankind because of the scale of the solar minimums coming. They are huge.
Well, can we thank
And
you?
I-
Yeah, well, I just think,
that's
so
it.
what all we're saying is there's going to be a coming cold bit, and then it's not going to be then as cold as a lot of us have been saying, or some of us have been saying, around 2030, but then there's going to be a return of much colder, is what we're saying.
Return what?
Of much colder.
When?
You said there would be a return turning much longer, you say 2090.
That's been a very long side of it.
A very long time. No, it's all right. Well, I think the relevance of this, apart from, there's a lot of hard work in there, and the connections are probably electrical, involving currents, working currents. Okay, so
it starts late this century. The Grand Side.
So I want to thank Ulrich very much for this important contribution.
There's no theorising in it. It's all correlated to weather records and to solar data. There's no theory. It's just all findings, observations.
Chantal?